Were they happy like anyway?
Honestly, like say
Alright guys,
fan.
so today what we're going to be continuing with is an exploration of the derivative and what the derivative actually tells us, okay? What the value of that derivative can tell us about the original function. We can find out a lot of things about it, and that's what we're going to explore, okay? Pretty cool? Bless you. So I went to a training this weekend at A&M in Corpus for my UIL kids, and the guy was talking about the UIL competition and what usually children struggle the most on that number sense test, and he says that it's the estimation problems. Kids have a lot of trouble estimating because they're not used to doing that in their classes. So we're going to practice a little bit on estimation. We're going to estimate the derivatives at different places. Sounds good? And then we're going to use that derivative, bless you, to determine something about the function, and we're going to write the equation of the line so we can practice that for tomorrow. Ready? So let's see how fast we can get through this. Here we go. So, what is the derivative? Slope of the tangent line. So that's what we're finding. The slope of the tan line. And it's denoted by a what? What is that symbol called? Starts with a P. A prime symbol. Very good. We're going to call this function over here f of x because they didn't label it, okay? Good? Alright, so here we go. We want the slope of the tangent line at -7. So what I want you to do is I want you to use your ruler, and I want you to put it at -7 and kind of approximate what would be a good slope to use there. Okay, so try to pick another point somewhere to where you can figure out the slope between both of them. I think this one would be a good one to use.
Yeah.
If I connect this point and the point of tangency, it makes a pretty good tangent line. What do you think? What would be the slope if I use this particular point? How many do I rise?
4.
And how many do I run?
1.
1. So an approximation for the slope of that tangent line would be 4. Okay, cool. Is the function increasing, decreasing, or does it have a max or a min at that particular point? It's decreasing? So the graph is going down? Remember, we look at it from what? Left to right. So if I'm on the graph, what's happening? It's increasing, right? So it is increasing. Why do you think I can say that it's increasing?
It's going up.
It's going up because as I move to the right, okay, that's a good answer. But why do you think this would tell me that it's increasing? Because the sign of the slope is what? Positive, right? The sign of that derivative is positive, therefore it should be increasing. Do you remember doing this in pre-calc?
No.
No? Do you remember finding where the function was increasing or decreasing? Yes, but maybe your teacher didn't relate it to calculus even though they should have. So that way they could bring that idea already, okay? Alright, anyways, so far so good? Alright, for the equation of the tangent line, what do we need? We need the point of tangency and we need the slope of the tangent line and we need this equation, right? Y minus what? Equals times x minus x1. Beautiful. Okay, so let's find all three things so we can write that equation of that tangent line. What's the point of tangency? -7 comma what? How would I figure that out? Plug it in, but there's no equation. Look at the graph, right? So where are we at? -3? Beautiful. And what's the slope that we came up with as an approximation? Alright, so let's write the equation. What's it going to be? 5 plus 3, 4 times x plus 7. Are we okay that I jumped and put plus instead of minus negative?
Yeah.
Yes? Are we okay? We're at that level, we can do that?
Yes.
Alright, thank you. Okay, so let's try the next one. -6. What would you figure out that approximate slope be then? So looking at -6, let's try to pick maybe this point right here. Does that make an okay tangent line? Yeah. How do I get from this value to this one? How many do I go up?
2.
To the side? 1, so what's the approximate slope of that tangent line? Positive 2, okay. So is the function still increasing at that value? Yes, okay. So if I look at the curve, I'm still going up. I'm still increasing right there at that particular point. Alright, so let's find the point of tangency, and the slope of tangency we already know is 2. What's my point going to be? Negative 6 and 0, so can we write the equation of the tan line? Y minus 0 equals 2 times x plus 6. Beautiful. We're going to write them all like that. We're not going to make them y equals. Good? Alright, what happens at negative 4? What's the slope of that one? 0, right? So for that one, we should be able to say f prime of negative 4 is not approximately, we can actually say what? Is 0, right? So let's say that it is 0. Okay, so is it increasing or decreasing there? Is it increasing or decreasing?
Relative.
No, right? But we know that it is a what? Relative maximum. What's up with that word relative? What does that mean? Why can't we just say it's a maximum?
Because it goes higher.
Oh, so there's various maximums. So there's another maximum over here, right? Okay, so this is a maximum only relative to what? To that particular what? Interval or area, right? So in that particular area, that is a maximum. So it's relative to that area, it is a maximum. You understand? Yeah? There's something also called absolute maximums. What do you think the difference is?
Absolute is just like the highest.
So absolute is the highest of all the maximums. Cool? And relative is only in that particular area. Understand? Alright, let's do it. What's my point and what's my slope? Bless you. Negative 4 and what? 2? Alright, write the equation. Y minus 2 equals 0 times x plus 4. Papitas? Alright, let's keep going so we can finish. What's the next one going to be? What's the approximate value of that derivative? You tell me. Like this? One down and one to the side? Is that okay? I picked this point right here, so it's one down, one to the side. So that gives me a slope of what? Negative 1. Ooh, so what do you think is going to be happening? Decreasing? Is that what's happening? Is the curve going down? Yes. Why do you think it's going down? Because the slope of the tangent line is negative. Because the derivative is negative. How do I know that I have a max here? What has to happen in order for me to have a max? The slope has to be 0, okay. Not necessarily. Something else also has to be true. Has to be at the highest point. So how can I get it to be the highest point? What has to be happening? The function has to be going what? Up and then down. So that means it has to be increasing and then decreasing. Is that what's happening? Yes, so it changed from increasing to decreasing, therefore I have a maximum, okay? The derivative changed from positive to negative, okay? And it was equal to 0 at that value. So it's two conditions, okay? Cool? Alright, let's go. What's my point and what's my slope? Point is negative 2 comma 1. Let's go write the equation. Y minus 1 equals Negative 1, x plus 2. Very good. Easy? Alright, a couple more. F prime at negative 1. What's that one going to be? Maybe negative 2? Like 2 down and 1 to the side? Are there any wrong answers here? No, why are there no wrong answers? They're estimations, right? Some estimations just might be what? Better than others, right? So here we can say we're going to estimate negative 2. And what's happening? Is the function increasing or decreasing? Decreasing. Again, how can we tell? Just by looking at the derivative? It's what? It's negative. So you see a negative derivative, I know that the original function better be decreasing. Okay, it has to be going down. Alright. What's my point? My slope. Negative 1, negative 1. And this is negative 2. So we have y plus 1 equals negative 2 plus 1. Beautiful. Kindergarten stuff? Alright, now what happens at 1? What's the slope at 1? Ooh, is that a maximum, Monse? No, okay, so see how when the derivative at a value is equal to 0 doesn't necessarily mean that it's a maximum, right? It could also mean that it's a what? That it's a minimum, right? So I have to have something extra to determine which one it is, right? So we said for it to be a max, it had to change from positive to what? To negative. What do you think it has to be here? Negative to positive. So we'll see if that's what happens in a little bit. But we know that this is a relative what? Minimum. Okay, minimum, Gabriel, because it's what? Okay, it's at the bottom. And it's relative because the graph goes further down, right? So it's not the lowest point, but it's one of the lowest points. This is where my sales were really low, so iPhone decided to release what? A new phone, so my sales can go back up. Got it? Alright, cool. So, what's my point here? 1 comma, negative 4. And we said the slope, again, was 0. So we have y plus 4 equals 0 times x. Good. 3 more and we're done. Sort of. What's the derivative at 3? We said that it has to be increasing, right? In order for us to consider this to be a min, even though we already know it is. So let's see. Is the slope positive? Yes? Alright, what do you want it to be, your estimation? 2 up and 1 to the right? Would that be a good one? Can we make a better one? 4 up? 1, 2, 3, 4, and 1 to the right? Ooh, that's a really good one. Yeah? Good job, Diana. So 4 up and 1 to the right. That's really good. Okay? The other one was not wrong, it just wasn't as good, right? So,
A for effort.
A for effort, right? We want the best estimate. So this is approximately, and we haven't been putting approximately. Oops. We started at the beginning and then we stopped. So this is approximately what? 4? Okay. So is the function increasing or decreasing at that particular point? Increasing, right? The curve's going up. Why is it increasing? Because the derivative is positive. Because the slope of the tangent line is positive. Okay? Say what I say so you can practice hearing yourself. Alright, so what's the point of tangency? 3, negative 1. And the slope we said was 4, so my equation should be equal 4 times x minus 3. Good. two more so we can finish this investigation. And it did end up being decreasing to increasing, right? I gotta be going down and then coming up in order to create that loop on the bottom so it can have a minimum. Alright, what's the derivative at 5? 0 again? Uh-oh, so what does that mean? What could I possibly have there? A maximum or a minimum? What do I have to look at? I have to look at the change from either side, right? So what was happening on the left side of it? It was what? Increasing, and then on the right side? Decreasing. So it's going from positive to negative. It's like Pitbull, right? He likes to turn positives into negatives? Or is he like the other way? He turns negatives into positives, right?
What are you talking about?
It's okay. You don't know what Pitbull is?
I do.
The bald
I do,
one.
but like
The bald one.
yeah, the bald ones.
Yeah.
Are you referring to a song?
Yeah.
I've never heard this.
He turns negatives into
I
Positive.
can't think of
I can't picture him saying it.
That's the one where like he's talking about the Kodak.
Alright. So,
To my life from
we know that it's a maximum because we can see the graph, and we also know that afterwards, the slopes will be what? Will be negative, right? And the function will be decreasing. Okay, so what's the point of tangency there?